Hello, welcome back to the channel. So let's do one more question on area bounded by two or more curves when there are breakpoints present in your sketch of the functions. So in this question, we have to calculate the area of the finite region bounded by the curves x equals 0, x equals 3. So x equals 0 is this one. This point would be x equals 0, x equals 3 is a vertical line which passes through x equals 3 point, y equals x plus 2 and y equals x square. So by looking at the question may seem intimidating, but basically you have to calculate the area between the regions y equals x plus 2 and y equals x square from x equals 0 to x equals 3. That is the basic question about that. So again, in order to solve these questions, we first calculate the intersection points. So in order to calculate the intersection points, we first will equate the y values over here. So if we equate the y values, we'll have to equate x plus 2 equals x square in this case. So in order to simplify this equation, I'll move all of these terms to this side, and this would become x square minus x minus 2 equals 0, right? So again, if I have to factorize this equation, it would be x square minus 2x plus x minus 2 equals 0. So x times x minus 2 plus 1 times x minus 2 in this case. So the roots in this case would be x equals 2 and x equals minus 1 in this case, right? So since I'm concerned with only x equals 0 to x equals 3, I can see that x equals 2 lies between my area calculation point. So that is why this gives me an idea that x equals 2 is a breakpoint in this case. And since x equals 2 is a breakpoint in our case, in our interval, we'll have to check if our breakpoint changes the heights of our vertical strips before the breakpoint and after the breakpoint. If the heights of my vertical strips changes, so I'll have to consider that point by looking at the sketch of the function. So now we will again cover the concept of area calculation when there are breakpoints present. So if you have not watched my previous video on the breakpoints, I would highly suggest you to first watch that video in order to get the full idea about this video. So now we know that x equals 2 is a breakpoint in our case, and now we have to sketch the graph of both of these functions. We know that y equals x plus 2 is a line which passes through y equals 2, and y equals x square is a parabola, is an upward parabola which passes through the origin. So when we'll sketch the graph of both of these functions, this will be the sketch of both of these functions, right? So this is our y equals x plus 2, this is our y equals 2 point, and this over here is our parabola y equals x square. And you can clearly see in this case that x equals 2 is an intersection point, and it is a breakpoint as well, because before x equals 2, the y values of a line function are greater than the parabolic function, but after the breakpoint, after x equals 2, the y values of a parabolic function are greater than the y values of a line function in this case. So that is why while taking the total area, we'll have to break our whole interval from 0 to 3 into two parts. The first part would be from x equals 0 to x equals 2, where our y values of the line function are greater than the parabolic function, and the other part would be from x equals 2 to x equals 3, where our the y values of a parabolic function are greater than the y values of a line function. So that is why again we'll have to take two different strips. I'll consider one arbitrary strip over here represented in green color, and I will take one more arbitrary strip over here in the interval from x equals 2 to x equals 3 in this case. So that is why again, while calculating the area in this case, from x equals 0 to x equals 2, our y values of the line function are greater than the parabolic function. So the height in this case, since this upper y value is dependent on the line function and the lower y value is dependent on the parabolic function, the height of my vertical strip in this case, the height of my green vertical strip in this case would be x plus 2 minus x square, right? Because the upper y value is based on the line function, the lower y value is based on the parabolic function in this case. But from x equals, I'll use a different color, but from x equals 0 to x equals 2 to x equals 3, the height of a blue strip would be x square minus x plus 2 in this case, right? Because in this case, the upper y value is based on the parabolic function and the lower y value is based on the line function over here. So now we have considered the different heights of our vertical strips based on the breakpoint, which are this and this. Now, in order to calculate the total area, we'll represent the total area in the form of definite integral again. So the total area would be from x equals 0 to x equals 2, we would have x plus 2 minus x square dx, plus from x equals 2 to x equals 3, we would have x square minus x minus 2 times dx in this case. And when you will solve this definite integral, you'll get the total area bounded between both of these curves from x equals 0 to x equals 3 in this case. So I would leave the integral calculation to you, and I would highly appreciate if you can write the answer to this definite integral in the comment section below. So that's it for this video. I hope you got a good idea about these type of questions when we have breakpoints in our area calculation questions. So feel free to comment down if you still have any more doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.